Hello everyone, today we're going to continue our tree data structure part 4 out of 5. We are on our track to learn to extract useful information out of tree using recursion. But before doing so, we need to understand what function call stack is and what is recursion itself. And that's what exactly we're going to learn today, function call stack and recursion. This tutorial is a part of the data structures and algorithms class. First, what is a function call stack in JavaScript? Function call stack is a popular concept. It can be found in many other programming languages, and it's actually a fairly simple concept. Function call stack is simply just a stack data structure to keep track of the chronological order which the functions are called, and the order of calling the function is top down, left to right. The function which is in the line of code above is called before the function in the line of code below. If there are multiple functions in the line of code, the functions on the left is gonna get called first, and then the function on the right is gonna get called after, one by one. So top down, left to right is the normal order when the computer executes the code. Then why do we need a stack to keep track of this order? Well, the answer is, very often in programming, the computer has to process a function which depends on the outputs of another functions. When this dependency happens, the computer has to pause processing the current function, put that function into the stack, and then execute the other functions to get the outputs that the original function requires, and then continue to process that original function. In short, using a stack is the way the computer processes a function which depends on the output of other functions. Let's have a look at this example in this picture. By looking at the stack, we know that the console.log function is called before the getAvailableCache function. Why? Because it's the nature of the stack that anything comes first stay at the bottom. For the console.log function, we want to print out our available cache, but we don't know how much it is. So we need to call the getAvailableCache function. GetAvailableCache function is gonna return the cache amount that we have. So our function console.log is depending on output of the getAvailableCache function. GetAvailableCache is also put into the stack, and it returned 300. When getAvailableCache function is finished with the return value, it is removed from the stack. Then the computer continues to execute the next function on the top of the stack, which is our console.log function. And because we already have the input we want, 300, and now the console.log has the input it needs, the computer will print 300 out and empty the stack. We should note that stack is a stack data structure, and it has the max stack size. The maximum stack size varies depending on each browser implementation. For example, for Safari 9, the maximum stack size is around 63,000. For Chrome 51, the maximum stack size is around 41,000. Maximum stack size is an important information to keep in mind, because if we're not careful in our program, we're gonna exhaust the max stack size, and it will crash the program. There's an important note to remember for understanding recursion. That is, the next function will not be executed if the current function is not done. We will see a lot of examples about this note in a minute. Next, let's have a look at a simple function to see function call stack in action. Right here we have a really simple function. The first 3 lines is the declarations of the 3 functions. The first function gets stock price, we're gonna return 10. The second function gets stock purchase price, it's gonna return the total amount of money we have to pay for buying the stock. That equals to the number of stock we want to buy, multiply with the individual stock price. The third function is going to return our available cache, which is 300. These are function declarations, so none of these go into the call stack. Now in our line 4 of code, we want to print out our available cache. So our console.log function will be put into the stack. And because the input of our console.log function is not known, and we need to call the getAvailableCache function to get this number. So console.log will be here and wait for its input, and the getAvailableCache function will be put into the stack. Then the getAvailableCache function is executed and return 300. That's when it finishes and is removed from the stack. And now we know console.log input is 300. So our program is gonna print out 300 and it empty the stack. This example might sound simple, but it demonstrates 2 very important concepts that you should vividly remember that is line 5 of code. This one will not run if line 4 of code has not finished. We can imagine that in reality, this function getAvailableCache can depend on many or hundreds of other functions. And line number 5 is still waiting for all of those functions to finish. That is how synchronous code execution works. Top, down. The second thing is the computer is executing code left to right. Console.log is got called first, and then getAvailableCache get called after. Okay, if we remember all of that, understanding the last line of code, line number 5, should be fairly straightforward. In this one we call console.log. Console.log doesn't know the value to print out, so it goes into the stack, waiting for the input. And then we have getPurchasePrice with the input of 20. So 20 multiplied with the stock price. And we don't know the stock price. So getPurchasePrice go into the stack, waiting for the input of the stock price. And then getStockPrice is called, and it returns 10. Then getStockPrice function finishes, and it's removed from the stack. Now we have the stock price is 10, so we can calculate the purchase price. 20 multiplied by 10, that's gonna be 200. Then the getPurchasePrice function is finished, and it's removed from the stack. And now we know the purchase price is 200. Console.log has its input, and it prints out 200. It finishes, and the stack is now empty. You might wonder why we're going so much into details of these two simple functions, and they're called stack. The reason is this is the key to understand recursion and complex, multiple recursive call within one function. That means no matter how complex your recursive function is, if you can understand and remember this, and diligently draw out your call stack, you will be able to figure out the correct order when the functions gets called. And the correct order when functions are called is the order of node selection when using recursion to extract useful information out of the tree. No matter how simple or complex your recursions are, they all following these rules. Next, we're gonna learn about recursion. A formal definition of recursion is if a function has two following properties. One, it has a simple case or many simple cases that lead to the scenario that it doesn't have to use recursion to produce an answer. And two, it has recursive step. The step can contain one or many rules that reduces all successive cases toward the base case. If a function had these two properties, it is a recursion function. For example, that we have a recursion function factorial here. This function is gonna return the factorial of a given number n. So in this line, we have the first property. This is a terminating scenario. Whenever n equal to 1, it's gonna return 1. And this is the recursive step. That's when if n is not equal to 1, it's gonna return n multiplied with factorial n minus 1. And because n keep minus 1 in the recursive call, eventually it's gonna lead to this base case, which is when n equal to 1. This factorial function satisfies these two properties. So we call this factorial function a recursion function. If we observe the call stack of a recursion function, which we're gonna do later, we will see that in the call stack, all the cases stack up to wait for the base case's outputs. This observation is very important, and we should remember very clearly because it's gonna help us to visually understand and build solutions based on recursions. We also have an informal definition of recursion, which is recursion function is function that calls itself, and usually with different input data. In that case, we can think of recursion function processes data point after data point with the same logic by calling itself again. This might sound strange to human intuition, but for computer it makes perfect sense. Because as we learned previously, a single core computer only processes a single data point at a time. And because recursion is gonna put a lot of function calls into the call stack, so normally data passed into the recursive call should gradually exhaust to make the call finally hits the base case and resolves the call stack. Otherwise, the call stack gonna have the error of exceeding maximum call stack size. Now let's have a look at the details of the simplest recursion function, factorial of n. So we have the base case here, and we have the recursive call here. The base case is gonna return 1 if n equal to 1, and the recursive call gonna return n multiplied with factorial of n minus 1. Let's try factorial of 3 and see how this function can produce the factorial of 3 equal to 3 multiplied with 2 multiplied with 1 equal to 6. By our understanding about function call stack, when this line runs, This is what's gonna happen in our call stack. Console.log function is gonna go to the call stack first, and then it will wait for the output of factorial 3. And we have factorial 3 equal to 3 multiplied with factorial 2. And that's what we have here in the call stack. And factorial 3 is waiting for the output of factorial 2. And factorial 2 equal 2 multiplied with factorial 1. So factorial 2 go to the call stack and wait for factorial 1 output. And factorial 1 will return 1. So that's what we have here on the top of the call stack. Factorial 1 equal to 1. And at n equal to 1, we don't have any further recursive calls. Factorial 1 returns 1 and finishes. And we go to factorial 2 equal to 2 multiplied with factorial 1, which is 1. Then factorial 2 returns 2 and finishes. Then we have factorial 3 equal to 3 multiplied with factorial 2, which is 2. Then factorial 3 returns 6 and finishes. And then we have our console.log of 6. So that's how recursion create our desired values here. First we have 1, then we have 2, then we have 3. If we look at the code stack at the beginning, we can see that all the cases stack up and wait for the output of the base case, which is factorial 1. If we want to calculate the factorial of 1000, we're gonna have 999 factorial functions stack up in our stack, waiting for the base case output of factorial 1. You should visually remember the image of the stack, with all the recursive calls waiting for the base case output, to understand the nature, how recursion solve a problem. Because recursion is a very powerful tool in programming. To calculate the complexity of the recursion functions, usually we can draw out a recursion tree. Like this one, factorial 3 gonna call factorial 2 and factorial 2 gonna call factorial 1. And we can see the pattern with the tree and generalize it. And the tree is gonna linearly grow with the input n. So the time complexity of this recursion function is O(n). Next, we're gonna look into a more complex example of a recursion function, which has multiple recursive calls. Our example function is fifth. This function is gonna return a Fibonacci number at a position n. You might recall that a Fibonacci sequence is a sequence of numbers. The first number is 0 and the second number is 1. Going forward numbers is the sum of the two immediate numbers before it. For example, 1 equal to 0 plus 1, and 2 equal to 1 plus 1, 3 equal to 1 plus 2, and so on. Our function is going to return a Fibonacci number as position n. For example, for this one at position 4, it returned 3. The sequence is 0 indexed. Our first position is position 0. These two lines are our base cases. If n equal to 0, it's going to return 0, which is our first number in the sequence. If n equal to 1, it's going to return 1, which is the second number in the sequence. And this is our recursion step. In our recursion step, we have two recursive calls. The first one is fifth of n minus 1. The second one is fifth of n minus 2. We sum up these two numbers and return its sum. If we run fifth of 4, it's going to return 3. This is no surprise for us, but what we're gonna learn today is we're gonna really deep diving into how our program produces this number 3 and why do we have n printing out like the sequence that we have here. Why is it important to know this? It's because that if we have a recursion tree like this, knowing the sequence of which function is executed first is important in many cases. For example, if we use recursion to visit all the nodes in a tree, we need to know exactly what node we're gonna visit first, because that's gonna dictate the outcome of our final result. At this point, you already learned everything you need to figure out why n is printing out in this pattern, and what fifth function in this recursion tree gets called first. So if you want to try to do it yourself, you can pause the video and work on it for a little bit. It's gonna help you to remember this longer. I'm gonna give you 5 seconds to pause the video. Okay, let's run this program together and use our call stack to see why n is printing out this way and the order of fifth functions get called first in this recursion tree. You might notice I already wrote down the sequence of which fifth is gonna get called first, and I also color coded in blue, purple, green, yellow, and red. So it's gonna go like this: 4, 3, 2, 1, 0, 1, 2, 1, and then 0. Why fifth function gets called in that sequence. Let's have a look at our call stack. When this line runs, console.log fifth4 is put into the stack, and because we don't have the outcome of fib4 right away, so fib4 is gonna be put into the stack. And fib4 equal to fib3 plus fib2, and right here we have n of 4 printed out. But we don't know about the outcome of fib3, so fib3 is put into the stack, and n3 is printed out. Fib3 equal to fib2 plus fib1. Fib2 is put into the stack, and n2 is printed out. Fib2 equal to fib1 plus fib0. Then we need to calculate fib1, and fib1 equal to 1, and n1 is printed out. So that's how we have n from 4 to 1 printed out. So fib1 return 1 and it finishes, so it's gonna get removed from the stack, and we have the value of fib1 is equal to 1 here. Then now fib2 equal to 1 plus fib0. So fib0 is put into the stack, and n0 is printed out. And then fib0 returns 0, and fib0 finishes. Then we're gonna have fib0 equal to 0 here. Then we have fib2 equal to 1 plus 0. Then fib2 gonna return 1, and fib2 finishes. Then we have fib3 equal to 1 plus fib1. And fib1 is going to be put into the stack. Then we have n1 printed out. And we are right here in this recursion tree. Fib1 return 1 and finishes. And then we have fib3 equal to 1 plus 1. Fib3 equals to 1 plus 1. So fib3 is returned 2. So we have fib4 equal to 2 plus fib2. Fib2 equal to fib1 plus fib0. And n2 is printed out. And we are right here at fib2 number 4. Fib2 equal to fib1 plus fib0. Fib1 is put into the stack, so we have n1 printed out. And fib1 equal to 1, and that's this function right here in our recursion tree. Fib1 return 1 and finishes. Then we have fib2 equal to 1 plus fib0. Fib2 equal to 1 plus fib0. Fib0 is going to be put into the stack, and we have n0 printed out. And that's gonna be our final fib function in our recursion tree. Fib0 returns 0 and finishes. So fib2 equal to 1 plus 0. Fib2 equal to 1 plus 0 is gonna return 1. And fib2 finishes. Then we have fib4 equal to 2 plus 1. Fib4 equal to 2 plus 1 equal to 3. And fib4 finishes. Console.log of 3 is gonna print out 3. So that's how we have number 3 here. And all functions in our code stack finished. By using the stack and run the program, we know exactly the sequence how the fib function gets called in our recursion tree. And we know why our n is printed out this way. Recursion is a very powerful technique in programming. You can see that we can solve a problem with just a few lines of code using recursion. Recursion is also a very popular programming method because recursion is so powerful, so you will see a lot of recursion in your future work or your future programming interview questions. And the key to understand recursion and to know how exactly it behaves is using the stack. This will conclude today's tutorial. Thank you for watching, and I will see you in the next video.